Hello, everyone. Good evening, fellow hackers, members of the jury. We are NLP, or Now Let's Proceed, and that comes from natural language processing, because that's what we are going to do. And in this talk, we will talk about three things, basically the problem, the solution, and we will end with a quick overview of what we did. And the problem is fairly simple. It's finding information. And it's not just finding information, because that's quite easy, but finding information that is relevant, that is reliable, and that is structured. Because in this day and age, we're loaded with information, and health care information data is 85% unstructured data, exactly. And what we would like to do, or what would be nice, if that there is a system in place that can provide you the data in a structured way, also based upon who you are. Because if you're a health researcher or a local health worker and you're looking for information, or if you're someone else who is infected with HIV, you're looking for different information. And that is what we're trying to solve. So we came up with a web application that structures this data, and on top of which we build a recommender system so that the information that is retrieved by the system is personalized, relevant, and structured.
And in order to do the structuring of the documents, we have decided to use a natural language processing that feeds the topics, the structured data, to a recommender engine, which afterwards is being used by the user interface. What is nice with this system, and why it's important for HIV, is that if we prevent people from getting drug resistance, then we can save them. If we give them the information that they are missing, then we can save them. And in here, we can see that in this particular example, we have trained a model for researchers. We have trained a model in order to be able to show the main topics that we have in our documents, which are available in English, because the model can be trained in all the languages. And also, the application, it's easy. Only 4 steps, and you have the information. You log in, then, if you want, you put a search word. You can see the different profiles for which we have thought about training the application. Here you see, okay, you are logged and you are searching for art, and then you have the recommendation. It's easy, it's fast, it's scalable, it gives the pertinent information for the persons. It can be directly put on the cloud, so everybody can profit. It can be used in collaboration, in sharing by different stakeholders. We are covering just a small part of the forest that can become a playground for this application. The system is learning by itself, it's autonomous, it provides relevant and valuable information for the people which are most in need for that information.
Any questions? Yes.
I was just wondering how you filter the information that will become available, because there's a lot written, there's a lot known. So if an individual has a certain search term, which, because if you would go thousands of findings.
Thank you for the question, because that's a really interesting question. In fact, Google only does ranking-based search. We are providing 3 types, in fact 4 types of algorithms. We are providing collaborative user search, we are providing content-based search, ranking-based search, and keyword search. And that means the application, based on how you interact with it, it will change, it will evolve. And also what's really nice is that based on the way people interact with it, somebody in behind can see, but in fact people are searching rather this term, and this term. So maybe we should concentrate on that, because people need that particular information. And what's also really interesting is that you don't have to be local. You don't have to be there in order to help people. You don't have to be on site in order to provide the insights that people need to get their treatment, to know what this disease is about. Because we are speaking about stigma. If people have to go to a facility center in order to have the information, maybe they won't do it. But if they can search that online, at home, and we have seen that, for example, in Kenya, 85% of the people have internet connection. And if somebody is informed, then we think they will react way better.
More questions?
What are your data sources behind this?
We have trained a model for now just on the research article in English. But the application itself has a part in which you can state the language that you're going to feed in the documents, the profile for which you want to fill in the document, to feed the documents, and also that it's really simple. You just create a folder, you give a name, you put the documents, and you say, make me the training for English, make me the training from French. And then it will automatically detect the language of the document, and it will only select the documents in that particular language to do the training. And what we can do as a further implementation for the application is to do automatic translation of the topics that have been already detected, automatic translation of the documents which are being fed in, so we can offer the same information with the same relevance in different languages.
Just a question to make sure I completely understand your concept. Who do you think will benefit more using this application? At which level do you think it will have the most impact?
All stakeholders.
Oh.
The answer is quite easy.
Yeah.
Because people can learn about their disease. They can learn what can happen if they don't take the treatment. Researchers can learn what are the other papers that already exist on a particular subject. Because what's also really interesting in the application is that it shows the topics that exist with the words that exist already. So when somebody is searching, he can say, okay, but in fact this is also linked to this, it's also linked to this, which makes that information that maybe he didn't even thought about is gonna pop up. And also in the recommendation itself, based on the profile of the person and the similarity with other users, we're gonna recommend articles that he didn't even search, because we start knowing the person. And by knowing the person, knowing the articles that he's reading and what he's liking, we can propose other subjects. And maybe he will decide not to read them, but at least he will be conscious about the fact that those articles exist also.
And just to throw some more light on your question, so why we decided to come up with something that it's not only going to help HIV drug resistance, but for other diseases. If we look at the situation of Ebola in Liberia, some community health workers got infected because they lacked rapid relevant information. And we think with tools like this, not only applied in the case of HIV drug resistance, it could prevent such situations in the future.
That is why we have said we have just covered one tree, but we have the complete forest for which you can directly deploy the application.
Well done. Thank you very much.
Thank you. And just one thing, thank you for this hackathon, because it's really nice.